This is a short video about the lens guard, an innovation to protect the lenses in ophthalmology. Every innovation is born when inspired by a problem. The problem we faced was the breakage of PRP lenses in the retina clinic laser rooms. Maybe due to accidental slippage of PRP lenses during the laser procedure. Many a times these lenses break when in contact with the floor, especially with the usage of gloves and visco. Many solutions have been attempted, like the soft flooring or usage of end seals to cover the broken lens edges, but none have been found to be fully practical. So we decided to embark on the journey to develop an innovative lens guard. First step was the origin of the idea of a lens guard. The next step was to design 3D print the lens guard. The third step was to design a suitable mounting mechanism for the slit lamp. And the final step was a pilot testing of the prototype. Some important points we had to consider: that the lens guard should hold the lens firmly. It should be easy to attach and detach from the lens. Should not interfere with the corneal contact region. Should be attached to the slit lamp or wrist to prevent fall on the floor. Shouldn't be a hindrance to the working or viewing area, and should be of low cost. With the assistance of an engineering student from VIT, the lens guard was designed using software-assisted 3D CAD model rendering. As you can see, this was a 3D model and the dimensions shown. With the help of 3D printer Ultimaker 3, using the material thermoplastic polyurethane, we developed and printed our first 3D prototype. First prototype fitted snugly with the PRP lens. Now the question was how to mount this onto the slit lamp. So the next step of development began. We tried a thread-mounted system in which the PRP lens hung from the midline at the center of the headrest, but was found to be not stable. Then we tried a clip-mounted system. This was found to be more stable, but a central anchoring mechanism was needed. So we explored more options. The first option we tried was to stick the clip onto the slit lamp headrest using a two-side tape, but was found to be not reliable. The next option was a screwed anchor flap, which was found to be stable. We decided to follow the latest mounting mechanism as shown here, using a cable tie to hang the lens guard from the center of the headrest of the laser slit lamp. It was hanging in the midline and could be accessed very easily. The final step in our development process was the pilot testing by mounting it on a Pascal laser system. After mounting it on a Pascal laser system, the first impression from the clinician was that the laser could be delivered very successfully. A constant upward pull was present on the lens. It led to air bubble formation and may cause a delay in the procedure. We were again faced with the question how to hold the drawstring in place. We needed a mechanism to lock or hold the string to reduce the tautness on the string, so this required further problem solving. We decided to use a thread lock for this purpose. Second prototype was printed. The lens guard assembly consists of a winding clip, a thread lock, and the lens holder itself. Let us look at how the lens guard is set up. The PRP lens is squeezed into the lens holder so that it is snugly held in place. Now, the lens guard is mounted onto the headrest of the laser slit lamp. After applying visco, the lens along with the lens guard can be applied on the eye. Laser can now be applied successfully. The lens guard was clinically tested. It showed it prevented accidental falls. The thread lock was found to be very effective. It's a request to reduce the size of the holder and to make it from silicone. In the future, we plan to develop lens guards for other lenses in ophthalmology as well, and also to refine the existing design. A heartfelt thanks to everyone for their support and help in the development of this lens guard. When creative minds come together, they can make the impossible possible and the ordinary extraordinary.